Hi, this is Mary Jo Webster from the Star Tribune. I'm going to talk today about how to interview your data. This is basically the step when you have your data in hand and you have an idea of where you want to go with it, but you're not quite sure exactly how to proceed. Um, every this is I wanted to do this session because there's so many times especially when I was a young data journalist, when I found myself just beating my head against my desk trying to figure out how to get what I wanted out of my data. I kind of had these visions of like what I wanted the answers to be, and I knew how to run all kinds of queries. I could work in Excel, I could work in a SQL program. I thought I knew how to do things, but I was really not sure how to proceed. I also realized recently that working with data is a bit like the game Chutes and Ladders, where you find little shortcuts or things that help you make a good progress, and you hit one of those ladders and you go up, 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 and you're moving along, and then all of a sudden something goes wrong and you hit one of those chutes, or you forgot a step and you realize, oh my gosh, I have to go all the way back and redo a whole bunch of things because I screwed up. Or you forgot something or whatever. So my goal with this session is to try to help you find the ladders and avoid the chutes. So some basic things to start with: always have a backup copy of your file of the original file somewhere away from wherever it is right now, the one you're working in. And then a big one is to have a data diary or a journal of some sort. This could be on paper, this could be in a Word document. If you're doing some coding in R or Python or something like that, you could do it right in your script possibly. There's a lot of stuff you might also want off to the side. And I've always kicked myself when I somehow skip this step or decide, oh, I'll be fine, I don't need it. Trust me that when you get a month down the road or 6 months down the road or a year down the road, you will not remember what you did. The other big thing that can help with a data diary, especially for those of us who um, are so busy in our jobs that we might only get to work on our data project a little bit here and a little bit there with big gaps in between, a data diary can be a great way for you to pick up where you left off and to be more efficient in when you do pick it back up again. So your data diary right away should include a description of the data, where you got it, contact names, the people you dealt with, if a copy of your data request, if you had to file one, if you got it off the web, what's the web page where you got it from. Anything unusual that your future self needs to remember? Is there some caveat to the data that they told you about? Is this a certain range in time? Is this a certain universe of data, like only schools located in your metro area? Or is that in not all the schools in the state? Things like that. So and note where you stashed the backup copy, where you've stashed a record layout code book. Think of it as I kind of think of it as, if I got hit by a bus tomorrow, that somebody else could pick up and go run with this if I can't. So write it for somebody else. So one of the first things, and some of this research you could be doing even before you get your data, but definitely by the time you have your data, you should have answers to these questions right away. Understanding how it is used by the government agency and how they collect it is super important. I've heard many horror stories from other data journalists that did not ran into problems because they did not fully understand this. So one is from a good friend of mine, Janet Roberts, who, while at the New York Times, requested prescription data from Minnesota's medical program for the poor. She hoped to identify top doctors who were prescribing antipsychotic medications to children, and then compare that to a list of drug company payments to doctors. This was back at the time that Minnesota was one of the only states requiring companies to report payments to doctors. And she was working on the data for a while, and then she discovered some really strange irregularities in the data where a doctor in, say, Minneapolis was writing dozens and dozens of prescriptions for children located in northern Minnesota, hundreds of miles away. And so she contacted the agency that gave her the data, and they said, by the way, you should know that we estimate that 20% of the prescriber names are inaccurate. And she kind of was like, what? And it turns out that the prescriber information got entered at the pharmacy, most likely by clerks who take your prescription, and too often the name came from a scribbled signature. Yeah, so it turned out to be faulty and they couldn't use the data. So the other good thing about knowing how an agency uses the data is that you might find that maybe they've already done some analysis, or maybe there's something you could be able to use as a reference point, or there's somebody at that agency who does know the data really, really well and could answer questions for you. So get these questions answered right away. Then the next step is to what I call go on a first date with your data. Review the record layout and any other documentation. If they didn't give you a record layout, make your own and make sure you understand what all the columns are. Make sure you're not making assumptions about those columns. Make sure you know what each row represents. This is more important than it seems. I asked for some fire incident data one time, and I just assumed that fire incident data would have one row for each incident, and so that it would be easy just to count up how many incidents there were. Well, no. There was one row for each vehicle dispatched to that incident. So on a big fire, there could be 10, 12 rows for each fire truck, or even the chief's pickup truck that got dispatched out to a scene. And so I had to do a little bit of work to make that into what I needed it to be. Another way to understand your data, particularly if it's very complicated, is to pull out a single record or that single incident or one kind of piece of it so you can try to understand what it's telling you, and go through and evaluate and maybe even start writing a sentence that, the data shows that on June 2nd, the police department sent out 10 fire trucks to such and such an address, and here's what we know about that fire. We know that it was a single family home. We know that one person died. Whatever pieces that are in there that it would tell you, and just try to learn what it's saying and what you understand and what you don't. And understanding the universe of the data, what years it's covering or months or days, the places, and then whatever's missing. Is there something here that you thought you would have? So this is both in true of, did you get all the columns that you thought you were going to get? And then did you get all the rows that you thought you were going to get? Is this supposed to be January 1 to December 31st? Is there records for all of those dates? Things like that. Make sure you didn't miss anything. So now here, if you have unanswered questions to any of these things, or there's missing things, I'm sorry you hit one of those chutes, and you're going to have to go back to the agency and get some questions answered before you can proceed. But if you're good to go, you can proceed on to the next step. So this is probably the most crucial. You need to find the flaws before they will find you, because they will. I can guarantee this from 20 plus years of experience. Any problems in the data will come back and bite you later if you don't nip them in the bud right away. So you should be looking at all the values in each column, make sure there's not inconsistencies or huge outliers. Are there any columns that have too many blank or null values? Look and see if there's something you're certain should be there. So for example, a colleague and I were looking at data on police chases in Minnesota. Each police department is supposed to report to the state details about anytime they start a chase with somebody, a vehicle chase. And we had several high-profile incidents where pedestrians had been injured or killed, and we had written about them. And so my colleague asked, well, pulled up those old stories and said, let's see if we can find these incidents. And there was a big one we couldn't find. And there's another one that we found, but we knew that somebody died, but the data didn't say that somebody had died. So that raised big questions about the validity of that data for us. And then try to ask one or two basic questions that you want to ask and see if you can get some answers. This is just kind of a test to see where you're at. It's pretty rare that an entire data set would be completely useless based on what you find here. There may be some data cleanup that you need. There may be a column that you wanted to use that you can't because there's too many null values, for example. But most likely you just need to rethink your approach or scale it back a little bit or change the direction you're going. And the other thing is that you might find things in here that you hadn't expected to find, and maybe it would show you a new direction as well. So if you do find flaws, then here's where you need to, we're going to need to do data cleanup, and I'm going to recommend you come back to that in a few steps here. Let's look at a couple other things. So another thing that you can start doing is preparing for your interview. A couple ways you can do that. First, write down in your data diary some working theories or statements. Like, what is it that you're hoping to find? What statements are you hoping to say in your story? So for example, I worked on a big project on sex assault investigations, and we were reading case files and building a database of each case and how they were handled by police and whether or not they resulted in charges and a conviction. And we knew up front that we wanted to be able to say something like, acquaintance rapes are less likely to result in a conviction than stranger rapes. That right there tells us that A, we need to track whether or not a case resulted in conviction, right? And then we also needed to know, was this an acquaintance case or a stranger case? In that case, we were building our own database, so we could bake that in right from the start. But let's say this was data you got from a government agency, you need to know, is there a column that would indicate the relationship between the victim and the assailant? Another example, a colleague of mine requested from the state suspensions and revocations of foster care licenses. And she specifically asked for, the names and addresses and the date they got their license and the date it was revoked, and then why the license was revoked. And the state kind of threw up a fit. Oh, this is going to be too hard. Well, it turns out that their database did not include a column identifying why the revocation. Their database was merely used as a kind of index of who had a license and who didn't and whose was revoked or suspended. That's all it was. It didn't have any of the details. All the details were in paper records. So she could not, her working theory and her big statement was impossible to do. And she would have been able to, if she had asked that question up ahead of time before she even got the data, she would have found that out early on. So make sure you have the information you want for the working theories and statements that you're hoping to achieve. And then prep for your interview. Remember your first day as a reporter, cub reporter, and you're headed out to interview the city mayor or some other person that you want to make sure you impress, and how much time you spent with your notebook writing down questions and preparing for that interview. Do the same thing with your data. Write down a list of questions that you want to ask. I've thrown some questions on here that are just really common ones that we seem to ask a lot with data, but these of course is not the end all be all, but it's a few things to help get you started. And think about even the most basic questions, the counting up the change over time, or how many here versus there, and the best and the worst and things like that. Even though that might not be your story in the end, it's going to help you understand the data, and you're going to want to ask those questions. Think about a interview with a human. You want to get as much knowledge out of them beyond just those main questions you're hoping to ask them. You want to know how deep their knowledge is, and it's the same thing with data. Okay, so now we're going to go back. Here's a case where you're probably going to end up on one of those shoots. If you do have to do data cleaning, it's time to go back and tackle that data cleaning. You keep in mind that you only need to clean columns that you're truly going to use. So for example, let's say you're looking at campaign finance data and the names of the donors are a mess. They're inconsistent all the time. But and the story you want to do is on who was the largest donor to a particular candidate. Then yes, you've got to clean up those names. But let's say you want to know how much did this candidate get from in-state versus out-state, and how does that compare to his opponent, his or her opponent. Then maybe you only need to clean up that state field and make sure it's consistent, and you don't need to worry about the names. Think about whether you need to add other data. Do you need some population data to calculate per capita rates? Do you need, is there some codes that are missing, or you need a translation of a code? Is there perhaps something else entirely? So here's an example. When the Minnesota Twins started playing in a new outdoor stadium in Minneapolis in about the early 2010-ish. They had a couple seasons where they just couldn't seem to hit a home run to save their lives. The other teams were doing just fine, and there were tons of theories about why can't the Twins hit a home run. And our baseball writer said the main theory circulating in the locker room was the weather, and more than just, hey, we're in an outdoor stadium now, we used to be in a dome, but it was something about the weather. And so we found a meteorologist who was also a baseball fan, and he gave us some suggestions about what weather might be affecting a game. And that was primarily wind direction, wind speed, precipitation, and humidity. And so we gathered all that for each at the start time of each game from the nearest weather station to the stadium, and we matched it together based on those dates and times. And then we were able to figure out that yes, it was the wind and the wind direction coming into the stadium in a particular way that made it hard for especially left-handed hitters. And at the time, the Twins roster was stacked with some really good lefties, and that's why they were struggling. And so but we needed that data. The game data alone, the hitting data alone would not have told us that. We needed something else. So think about what else you need to have. The other thing is data structuring. So let's say your data is wide, meaning there's lots and lots of columns, like one column for every year, or different groups, demographic groups or something like that, and you need it to be going the other way. Or maybe there's like that fire incident data where there's one record for every vehicle instead of one record for each incident. So there's things like that that you need to keep in mind as well. And that's all part of this data cleanup step. And I'm really sorry to break this news to you, but this is probably the biggest step of all, and it will probably take you the longest, and you should be prepared for that. If your data is not in the right structure or it's not cleaned up, you're not going to get the right answers. So you really need to pay close attention to this step. Some other things that you might need to do, one is putting data into buckets. So for example, let's say I frequently work with death certificate data on everyone who's died from an opioid related death. And the data comes with each person identified as their specific age, like 46, 32, 25. Well, in order to do trend analysis on whether certain age groups are being disproportionately affected by this than others, I need to create a new column putting each person into a bucket or an age group. So that's the idea of buckets. And I find buckets are probably the most common thing I have to do in getting my data ready. I just talked about the transposing rows and columns. You might also need to summarize your data. I frequently get school test scores and other school data where it's Sorry about that. I got disrupted. Now I can't remember what I was saying, but I think it was something about summarizing your data that oh, I know. I get school test score data frequently that comes with scores for each grade. And usually I want to summarize that up to the school level. So I have to add together all the grades, how many kids took the test and how many had a proficient scores, and then calculate new percentages from that to say what percentage of the students in the whole school were proficient on the standardized tests. And that's another common thing. It's really nice to have detailed data like that, but then it's not when you need to be able to say something from it. It's very hard sometimes to figure out what trends and patterns might be happening when your data is a little too detailed. So don't be surprised if you do need to summarize up to find the trends and patterns, and then rely on the detailed data for your anecdotes and your specific details that you might need for your story. Of course, standardizing values, that means like cleaning up the names. I had a data set once where I swear there was 15 different variations on how to spell Minneapolis, so I had to clean that up. Another one is eliminating duplicates. This is less and less common today than I think it used to be. I haven't seen it quite as much, but you want to be wary and make sure there aren't any duplicate records. I did get a data set once where it was essentially the checkbook register for a school district, and we found these strange duplicate records where it was going to the same vendor and for the same item, like what they were purchasing or whatever they were paying for. But then the values were, let's say it was $10,000 on one, and then the other one would be negative $10,000. And we later discovered that those negatives were actually voids, and they had forgotten to give us a column that indicated which records were voided checks and which were not. And so it looked like duplicates to us, but a really strange way of duplicates. But still it ended up truly being kind of duplicates in a way. So look for that kind of thing too. A reminder, don't forget your diary. Make sure you're noting all your data cleanup and additions or changes that you're making. Note any problems that you encountered and how you solved them, including any answers you got from a government agency. I'm guilty of not writing this stuff down enough. And then later on, somebody asked me, hey, can you write a methodology, or can you write an article for the IRE Journal or something about how you did this, and then I cannot remember, a year ago what I did. And this is even true with smaller things that you do kind of quickly, not those big projects. You still should be writing all this down. Then another step that is really helpful, especially when you're first getting started, is taking those questions that you wrote, the questions you want to ask, and translating them into the computer language. And I think this is where a lot of beginners struggle. It's like, oh, I got this great question, and I know how to do pivot tables, I knew how to do formulas and functions, but how do I marry those two things? And this is where I think it's just a matter of translating your questions. So for example, let's say our question is, are elementary schools more racially diverse than high schools in my metro area? So now break this down. So if you want only schools in your metro area, so you need a way to identify which schools are in your metro area, and that might be a column, that might be what county they're in. Maybe your data set is only metro area schools, so maybe that helps, but you need that. And then we need a column identifying which schools are elementary and which are high schools. You can't just have a list of schools with names unless, that's not even going to be enough. You have to have a column that says this is an elementary school, this is a high school, and it needs to be clear cut. And then how are you going to deal with the schools that are K through 12? What are you going to do with those? So think about that. And then, okay, so we're looking for racial diversity. Okay, so what's our metric? There's probably not going to be a column in there that says racial diversity, but there's something in there that lets you get there. And maybe you have to do the calculations. Maybe you have to maybe it just tells you how many white students, how many black students, how many Asian, etc., and that you need to calculate what percentage are students of color. But that needs to be its own column. So then we need to say, put the elementary schools in a pile, the high schools in a pile, and a pivot table is really great for that. And then calculate the racial diversity for each bucket by summarizing. So how many white students and how many students of color are there in elementary schools? And then what's that percentage? And how many students of color and how many white students are there in high schools? And what's that percentage? So do you see how we've kind of done several things here, including eventually summarizing and making the buckets? But you just keep in mind that your question probably has the clues for you of what you need to have in your pivot table or in your formula or in a group by query if you're using SQL or something like that. It's probably there. You just need to break it down. Here's another example. How many schools in my state are majority minority? Well, okay, what's our definition of majority minority? And what column in our data will tell us that? And then if we're saying in my state, then that means we need to have all schools in the state. And then this might be a simple, notice how we're saying how many schools. Think about what that answer is going to look like. It's going to look like one single number. And usually when it's that, you usually don't need to do a pivot table. A pivot table is more when you want groups of things, like in the previous example, high schools versus elementary schools. But when you want a single number, you might not need to get that fancy. In this case, maybe it's just a filter in a spreadsheet. And just filter it to the schools that have more than 50% students of color. And then count up how many rows you have. You could do it in a pivot table, obviously, but think about the simplest approach to get you there, and that'll probably do it. Let me give you a few quick other best practices to think about. Your data should be what's called tidy. So a neat rectangle of data. Headers, the column headers confined to just one row. No empty rows, no empty columns. Each row should be one observation. And that one observation could be many things. You know, like in the fire incident example, one observation was each vehicle. Okay. In the school racial diversity data, maybe one row is a school. So whatever that is, but it should not be multiple things. And then each column contains one piece of information. So this is really important if you're building your own data set. If you have a date column, you want that to only have a date, not anything else. If you need, and then let's say you have a name of somebody, maybe you have the last name in one column and the first name in another column, things like that. Use clear, concise column names. I think that's just a good practice. I highly recommend, especially if you're going to move out of Excel someday. And then your file name of your data files, something that is easy to understand. I get data files from government agencies sometimes where it's like F361025 or something strange that makes absolutely no sense. And I don't know what it is. So I try to rename it, maybe put dates on there, like when you got the file. That might be helpful. And then in an Excel file, when you have multiple worksheets, make sure you're naming your sheets as you go along. Don't just leave it as sheet 1, sheet 2, sheet 3, because a week from now you're going to go looking for something and you'll have no idea where to look. Don't assume that deleting data will be okay. You might regret that later. I'm speaking from experience here. I like to use hiding columns or just leaving them be if need be. As I mentioned before, make sure you know what the columns mean and the codes and values in those columns. Make sure you understand them and you're not making assumptions. Ask if you're even the slightest bit unsure. And don't assume that your data is perfectly clean. There really is no such thing. There's always some limitation to data. And And then finally, we can do find and replace in Excel just like you would in a Word document, but don't assume that it's not going to cause harm. It can cause harm because you really can't see everything that it's doing, so be cautious. Probably my biggest point is if you're doing something that seems unusually difficult, there is probably an easier way. And some of my other video tutorials will show you some of those easier ways. So especially if time is tight, uh, stop if you're hitting on something that seems a little too hard. Then the final thing here, you can a few things you can do to vet your work and make sure you've done everything correctly. Sometimes I start writing my methodology before I even write the story, and I even do this sometimes when we're not going to publish a methodology. I find that just the simple act of writing down everything I did helps me discover maybe something I missed or something I didn't think about, or maybe something I might have done wrong. It's always good to repeat your analysis start to finish, like just start with a clean slate. Maybe even try to do it a different way than you did the first time and see if you can get the same results. Ask a colleague to redo your analysis if you have somebody who can help you. Um, if not, even recruiting any colleague, this could be your editor, this could be another reporter. This person doesn't even need to have data analysis skills. Recruit them and just discuss your findings with them and say, hey, here's what I found, what do you think? And use them as a sounding board, and you'd be amazed that they might come up with something you hadn't thought about just by spending a little time thinking about something new and fresh. Remember, you've been deep in the weeds on this and you may not have the clearest view of it anymore. And always make sure your results pass what I call the smell test. If it seems too good to be true, it probably is. And this one comes from many years of experience as well. There's a lot of possibilities that something could have gone wrong in your analysis, that you had bad data to begin with, that could yield some result that is just too good to be true. There's the rare occasion where it is actually true and it's an amazing story, but don't assume that it's true. So there's my tips and tricks. Good luck interviewing your data.